So I think without further ado, we can go hand over to the first speaker, who is my colleague, Wout De Nolf from ESRF. Wout, over to you.
Okay, so hello everyone. My name is Wout De Nolf. I work at the data analysis unit of the ESRF. And I will start by presenting how we use HDF5 at the ESRF. So I'm a person with a scientific background. So I'm not a strictly speaking, a computer engineer or scientist or software engineer. But I do come from a scientific background, and somehow I got involved very heavily in HDF5. And so I will give an overview how I use HDF5, especially focusing on the part where the file is still changing, it's still moving. So it's of course writing the original data and the first data analysis. So we'll less focus on the things you could do, let's say when the file becomes static, like we saw yesterday with H5 Coro. So to start from the beginning, all data at ESRF is produced by BLISS, our data acquisition system, or at least this will be the case because the old acquisition system is still in use. And by switching to BLISS, we took advantage of changing all our file formats to HDF5. So BLISS is in charge of collecting data and publishing data, but not writing data. So data is published in Redis, which is an in-memory key value store. So when I say data, I speak typically about three types. So metadata in the sense of the scientific metadata. So it could be a description of the sample, a description of the beamline, motor positions, the status of the synchrotron, settings of detectors, and so on. So some of this could be considered data or metadata. I don't want to go into semantics here, but it's typically, let's say, scalar strings and numbers. I'll call that metadata. Then you have 0 and 1D data, which is produced by detectors like diodes and temperature sensors for 0D. And for 1D, you have MCAs or strip detectors. And then lastly, we have images produced by 2D detectors. Now, the images are not in Redis directly. Redis only contains references to another in-memory storage, which is managed by Lima. And Lima is our framework that manages all 2D detectors. So while data is being streamed in Redis, at the same time, HDF5 files are being written with a certain delay, of course. So at every beamline, we have a server running that basically looks at the Redis streams. So the data that's in there is only in there for, let's say, a limited amount of time. And so we need to write this, fetch this as fast as possible, write this to HDF5. In Lima, this is managed by Lima itself. So for 2D detectors, both the acquisition, the publishing and the writing is much more coupled than the rest of the data. So HDF5 files are written on distributed file systems. So we have GBFS and NFS for writing. And then our Windows clients have Samba as well. And the links, the URIs from Redis to Lima are converted to virtual datasets. We'll give a bit more details later on. So this is how the directory structure looks like of an experiment for a user. So we have 4 levels of directories, and they only contain HDF5 files. So no other formats or config files or additional metadata files or whatever. On the top level, we have one file which contains a single access point to all the data of an experiment. An experiment typically takes 1 day to a couple of days. So that's the proposal file, as we call it here. Then on the level below that, let me see whether I can use my pointer. I don't know whether everybody can see my pointer. Can somebody confirm?
Yes.
Yes. Okay. On the level below that, we have single access points to data collections. So a collection of data corresponds to, for example, all the data of one particular sample or one particular experimental condition. And then below that, we have the dataset files which contain the actual data, except for the images which are stored on the lowest level. So all these files are written in Python using H5 based on information from Redis. And the Lima files, Lima is a C++ framework, and so this uses the HDF5 library directly. Then if we go and have a look into one of these datasets files, by the way, when I say dataset in this context, I don't mean an HDF5 dataset. It's a dataset in terms of, let's say, the organization of data here. Then we see that the content of this file is conform with the Nexus standards. And the links from the top level files point to the top level entries in this dataset file, which correspond to scans in Redis. So the top level files don't contain any data. They only contain external links, basically. So all the data is in here. Now let's have a look inside one of these scans. And as I said before, we have several types of data. So you have metadata, you could also call this data, parameters and settings of detectors, for example. Then you have data that is saved internally in this file, all done in Python. So that's 0 and 1D detectors. And then there's the links to the external files, which are written in Lima. So the maximum shape of a data set is 3D, even though, of course, you can have higher dimensional data sets. But you will always have, let's say, the first dimension, which is basically a flattened view, let's say, in time of your acquisition. So what I showed you now, these are all the HD5 features that are being used. So apart from the normal things like groups and datasets and attributes, we use external links and virtual datasets, as I said. In terms of variable length data types, we use that for strings. All our strings are variable length data types. Datasets grow in time during the acquisition. I will show that a bit more in detail later on. And we make extensive use of chunking and compression. I will not go into details because the next speaker, Thomas Vincent, is going to speak a lot about compression, and also Jonathan Wright speak about compression, focusing on performance. So we'll not talk about that part. So as you notice, there's no mentioning of any swimmer or parallel HDF5, and so I want to go a bit more in detail of why that is. So of course you could say, well, we have NFS, at least partially, and so that already prevents us using swimmer, but there are more reasons. So to explain that a bit more in detail, I'm going to show you what happens during the writing sequence of one scan. So on the top, I will show you what happens in Python. On the bottom, I will show you what happens in C++ with Lima for the images. So when a scan starts, the dataset file is opened in append mode, and when the scan stops, it's closed. And then maybe some time later, a scan starts, and then the file is opened again. The first thing that happens is that some groups, or in Redis, some events are being streamed, and so the writer picks up these events, and based on that, it creates groups and attributes in this dataset file. And at some point, the first dataset is going to be created. Now, the shape of the dataset is not known at the start in general. So the shape will grow over time. In Lima, this is done typically a little bit different. I mean, it could be done the same way, but in practice, they do it a little bit different. They pre-allocate a particular shape. For example, they pre-allocate a chunk to save 100 images. And then over time, when these 100 images are full, let's say this chunk is full, a new file is being created and filled on. So this goes on until the scan is finished. And then at the end, the virtual dataset is being created. And also a number of additional attributes, typically some datasets. So one issue here is unfortunate, virtual datasets cannot grow in terms of the number of sources. So that means that if you want to do data analysis by using this file during the acquisition, you can't really use this as a single access point, at least not if you want to analyze the scan that is running. You can do it for the scans that have finished, but not for the one that's running. So because we have to make the virtual data sets at the end. So now if you want to do data analysis, online data analysis, you want to look at this file, and there are two ways. So there are two types of readers. So there are people who want to look at the files, the scans that are already finished. And then there are people who want to look at the scan that is actually running. So for the scan that is actually running, you could say, well, you could use the information which is in Redis and in Lima, but typically this software is written by scientists, and then they would have to support both HDF5 and Redis, and then whatever Lima does. So people just want to use the file itself. And so the only way to do that is to somehow enable Swimmer, but to enable Swimmer, let's say, for example, you have to know exactly when everything is being created in the beginning here, which you might not know, which you might not even know if there's no event that tells you that. Also, the file is opened, then closed, and partially in this part it's in not swimmer mode, and in the middle it's in swimmer mode. So readers that come in, they don't know basically what to do and when. So to summarize why we don't use Swimmer, we have NFS. There's no synchronization between reading and writing. So a reader can come in at any mode at any time. From the point of view of the writer architecture, we might not know when all data sets are created. And then there is support for software written in MATLAB and IDL, for example, which are stuck on HDF5 1.8, but that also goes for virtual data sets. So at some point, they will hopefully move on to a newer version of HDF5. So the current situation is that the file is open during scan in append mode, and we have two types of readers. So there's the standard ones which use file locking. So the file is not going to be corrupted. That's the good news because of the concurrent reading and writing. But the bad news is that either you stop the writer from opening the file, or you cannot open the file for reading. So the second mode is to open the file with locking disabled. Of course, in read-only mode, because if you do in append mode, if you do this in append mode, the file will be corrupted. The good news is that the writer is never going to be interrupted. It can always open the file. The bad news is that during reading, you can have exceptions and even segmentation faults at any time. So we have some tools in our CLEX toolbox, which contains primitives for data analysis, which is managed at the data analysis unit. But yes, it's not an ideal situation. Moreover, because we have to use an environmental variable to disable locking. And typically when you're doing data processing, you're reading one file, but also you're writing to another file. And so the environmental variable may be at the wrong value at the wrong time, especially when you're reading and there are external links and new files are being opened in the background. So that's a dangerous situation. But this is the current situation to do parallel reading while the file is being written at ESRF. So in terms of data corruption, so it's not going to be because of concurrent reading and writing, but there are other situations where data corruption can happen. So the disk could be full. It could be network issues, and the writer could crash. And so what we need is a tool to recover data from corrupt files. So one thing we might look into in the future, or maybe people, I would like to hear from people who have perhaps already solved this issue. But you could think of using a pure Python reader to browse through the files. So basically only go into the B trees and the messages and read the data sets with H5 Py. So the concluding slide is four future developments of HDF5, which we're very much looking forward to. So the first one is the VFD swimmer. So let's say a proper swimmer. And that's actually, it's a lifesaver for us, I think, at least in my opinion. So we still have some questions. What does it support? What does it not support? For example, variable length data types. Then the second is growing virtual data sets, so growing in terms of number of external sources, a tool to recover corrupt files, and a way to disable file locking through an API and not the environmental variable. So something that I have not discussed about is parallel writing, why we don't use MPI, but of course I don't have the time for that as I anticipated. So with that, I'll conclude and open the session for questions or comments. Thank you.
Thank you, Wout. So we have time for one or two questions. Who would like to? I haven't checked the chat, but I don't think there's any questions there. The thing is that. So there's a question from Elena. Doesn't printf option work for you?
Yeah, there is with VDS, there is printf option, but I believe source files have to be the same shape and names are generated on the fly. So you can add more you can add more source files.
You mean virtual data sets?
Yeah, there is a feature in VDS, so we can I can show you, and there is, I believe,
okay,
there is an example.
Well, I mean, we do this in H5 so maybe it's just that H5 doesn't support
I
it.
see. Yeah, in HDF5 there is a feature that you may generate more source files, and VDS can grow this way.
I see. Okay, perfect. That's just a matter of making it supporting it in H5.
Yeah, so I can answer a few questions on your bullet one. So yes, there are plans with a new swimmer that John Mazer will present later today. Enable support for NFS. But in the first release, there will no way of readers to come at any time. So there still will be some rules how readers access. I don't think it will support virtual data sets from the beginning, but it can be done. It can be extended, and it will support variable length. In your case, because you are using probably variable length data types, attributes, right? You are not writing variable length. Not be very efficient. It will not be very efficient, but there is a way to support it. So new swimmer will really help with NFS mostly.
Okay. So, but I think we have a good session on this afternoon. Yeah. Later at the end. Yeah. Just one. I don't know. Zedek, do you have a very quick question, or you want to take the discussion offline? You're still muted. You're muted.
I will have just a small comment, and because Elena already mentioned it, I think you can create virtual data sets before the target files are created. You can do it even with H5 Maybe you have to use the low-level interface.
Okay.
Yeah, it is not just visible in the high-level one.
Okay, thank you. So I would now say thanks again, Wout. Normally we'd clap, but it's a bit difficult.